All right, good morning, algebra students. Today we are going to discuss 3.3, which is function representations, different ways that we represent functions. So write down the title and let's get started. Okay, first of all, let's discuss what a relation is. A relation is any pairing of a set of inputs with a set of outputs. Very important. A relation is any pairing of a set of inputs with a set of outputs. So write that down. Okay, and a function is a dependency relationship where one thing depends on another. You already have this in your notes, so we're reviewing this. A function always has an input variable and an output variable. And to be a function, each input can give you only one output. All right, let's also review that the input is your independent variable, and it is the cause, it is your x values, and it is the domain. So your input is the x values. It's your independent, it's the cause, and it is the domain. And your output values are your dependent variable, it's the effect, and the y values, and it's called also the range. So make sure you understand and know these. Okay, we're going to be trying to identify when we have a function and when we don't. So remember to be a function, the x values cannot repeat. So if you're looking at a set of x and y values, the x values cannot repeat and the y values can repeat. And we'll look at some examples so you know what I'm talking about. So x cannot repeat and y can repeat. Okay, there are 5 ways to represent a relation. 5 ways to represent a relation, so you want to write these down. The first way is a set of ordered pairs. So here we have 3 ordered pairs, okay? And that is a relationship. So you have two x and y values that are put together. Then we also have what we call a t-table. So this is a t-table here. And this is a way to represent ordered pairs. So there's an ordered pair, there's an ordered pair, and there's an ordered pair. And then we can also graph the ordered pairs. So that would be a way to show a relationship. So here we have the graph. This is negative 1, 1, negative 1, 0, 2, and 1, 5. So that would be a graph. And then we also have what we call a mapping diagram. And here, this is where I list the x values here, and then I list the y values there, and then I map them. So I say the negative 1 goes with the negative 1 like we have in the ordered pair, the 0 goes with the 2, and the 1 goes with the 5. So I actually draw an arrow to between the x and the y. And then the last way is actually not a graph, but an equation. You can actually write an equation to represent a relation and a function. And the equation for this one would be, I think it's y equals 3x plus 2. So this would be 3 times negative 1, which is negative 3, plus 2, that equals negative 1. 3 times 0 is 0 plus 2 equals 2. And then 3 times 1, which is 3, plus 2 equals 5. So this equation represents that relationship. Okay, so be sure to get all of this in your notes. Okay, I think we have 5 examples. We'll see. All right, so example 1, write it down. You have ordered pairs here. These are your ordered pairs. And it says, give me the domain and the range of the ordered pairs. Well, the domain is your x values, so you're just going to list the x's. So first I have a negative 2, and then I have a 3, and then I have a 4, and then I have a negative 3. So those are my x values. And usually you put, what do you call that, the braces around the domain. And then we do the same thing with the range, and the range would be the y values. Remember, range is y. So I would list the y's. I have a 1, a 2, a 6, and a 4. And you can put them in numerical order if you want, but I'm just listing them. All right, it says, is this a function? And remember back when I said the x's cannot repeat and the y's can. So in order to determine if it's a function, you look at the list of x's and do any of the x values repeat? And if they do not, then yes, it is a function. Why or why not? This is because each input has only one output. So each x has only one y. So each input has only one output. So each x can only have one y that it is paired with. All right, so let's look at example 2. So now this is a t-table right here. So we've got a t-table, and we want to list our domain. So our domain, we're going to list them. -2, we put our braces around it. Then I have a 3 twice. So, and then I only write it down once. And then I have a 6. So only write the numbers down once if they repeat. And then the range is going to be your y values. So remember, domain is x, range is y. So y is going to be 6, 4, 3, and 2. Now it says, is this a function? And the answer would be no, it is not a function. Why or why not? Because the x values repeat. So we have an x, 3, that has, so the x values cannot repeat. Okay? Because 3 is matched with a 4 and 3 is matched with a 3. So the 3 has 2 different outputs. Okay, let's keep going. Okay, so write this one down. Here we have an example of what we call a mapping diagram. So now we have, this is my x's and these are my y's. So it says list the domain. So the domain is basically listing your x's. -3, -1, 0, 1, and 2. And then the range is going to be -3, -1, 0, 1, and 4. And now we need to determine, so again, the domain is your x, the range is your y. Is this a function? Remember, the x's cannot repeat. So if I look here, each x has to have only one y. So this has one y, but this -1 is paired with a -1 and a 1. And then this 2 is also paired with a -1 and a 4. So that means the x's can't repeat. So I have double arrows coming from a -1. That means that the x is repeating. So is this a function? No. Why or why not? Because because the x's paired with more than one output. Than one output. Now, if you want to get more specific, it's not just the x, but the -1 and the 2 are paired with more than one output. You have 2 paired with -1 and 2 paired with 4, and then -1 paired with -1 and -1 paired with 1. So that's the reason it's not a function. Alright, so here we need to draw this out. I know it's going to take a while. You can also print it out, cut it out, and put it into your notes, and then fill it in. So here it says, given the relation, complete the other 4 columns. So here's the relation right here. So we need to take this relation and fill in the ordered pairs, the t-table, do a mapping diagram, and tell me whether it's a function or not. So let's get started on this. First, I can do my ordered pairs. So I see that this first one is a -4, 4. So -4, 4 is the first ordered pair. And then this one here is a -3, 2. So -3, 2. And then the next one is -1, 3. -1, 3. And then the next one is 1, -2. Alright, so these are my ordered pairs. Now I complete the t-table, list my x's, -4, -3, -1, and 1. And my y values are 4, 2, 3, and -2. My mapping diagram, so I'm going to make a mapping diagram. And the way I do that is I draw two little ovals. And I list my x's in the first one. So -4, -3, -1, and 1. And I list my y's in the second one. And then I draw my arrows. So the -4 goes with the 4. The -3 goes with 2. -1 goes with 3. And 1 goes with -1. So each input has only one output. So is it a function? Yes. Or you can just put function. Alright, let's do the next one. Here we already have our ordered pairs. So now I'm going to list them in a t-table. So I'm going to list the x values, the -2, 3, -2, and 4. My y values are -3, 4, 5, and 4. And then I'm going to graph it. So -2, -3 is there. And then 3, +4 is going to be there. And -2, 5. And then 4, 4. So this are the ordered pairs. Then I do a mapping, which means I draw the little two ovals. And I list -2, 3, and 4. Remember, I don't repeat them. And then I have -3, no, I'm sorry, -3, 4, and 5. So I don't repeat them. And then I draw arrows. So -2 goes with -3. Then 3 goes with 4. Then -2 also goes with 5. And then 4 goes with 4. Alright, so looks like my -2 is repeating here. So the -2 is repeating. That's an x value. So is that a function? No, it is not a function. Alright, we have one more example. Okay, so here we have example 5. You're going to need to write this down. It says the domain for the function is given below. First, complete the table and identify the range. Then complete the other representations. So here's my function, y equals whatever x is plus 2. So my domain, remember, that's going to be your x values. So if I complete the table, I just list my x values, -1, 0, 1, and 2. So draw the table. And then I have to put in the -1, the domain, into the equation. So I take the -1 and put it in here. So y equals -1 plus 2. -1 plus 2 is just going to be 1. And then I take the 0 and put it here. So y equals 0 plus 2. Well, 0 plus 2 is just 2. And then I do the next one. Put in a 1 right here. 1. 1 plus 2 is equal to 3. And then lastly, I take the 2 plus 2, and that's equal to 4. Then I list the range. The range, remember, is going to be the y values. Domain is x, range is y. So I just list the range, which is, I'm sorry, let me back up there. So the range is going to be 1, 2, 3, and 4. Now, is this a function or not? Does each x only have one y? That would be yes. My set of ordered pairs would be -1 and 1. Then 0, 0, 2. Then 1, 3. And then 2, 4. Those are my ordered pairs. If I do a mapping, I list my x's, -1, 0, 1, 2. The y's I list here. My mapping, I draw lines. -1 is paired with 1, 0 with 2, 1 with 3, 2 and 4. And then lastly, I can graph this relation. So negative 1, 1, 0, 2, 1, 3, and then 2, 4. So there I have a relation, and it is also a function. All right, now you've seen all the different ways you can represent functions. You have mapping diagrams and graphs and t-tables and equations, and then listing the domain and the range. And that's it for our lesson. So have a great day.